Example 20. Determine the resultant completely with respect to point O of the force system shown below. So it means you just have to find the resultant force and its perpendicular distance or its distance from point O. Okay, so if you can observe, it's not the usual example we have. It is provided in boxes, right? And the length of each cell here is 1 feet, right? So 1 feet, 1 feet. Okay, and if we know that one, our 141.4 pounds we have going up. So let us call this one as force 1, and this our 300 pound as force 2, our 260 pound as force 3, and our 240 pound as force number 4. Okay, so we have F sub 1y going up, F sub 1x is to the right. We have F sub 2y going down. This is F sub 2y. And F sub 2x is to the right. We have F sub 3y going up. And F sub 3x is going to the right. And we have F sub 4y going up. And F sub 4x is going to the left. Okay, so if we do now the resultant moment, so resultant force. So resultant force F sub R. Okay, so this is the x component of our resultant force is equal to the sum of all the forces in the x direction, assuming upward positive. So this is equal to, we start with F sub 1, so that is 141.4, 141.4 pounds. Now for its ratio, now take note again that each cell is 1 by 1. So it means this is 1 and this is 1. 1, 1. 1 squared plus 1 squared, that's 1 plus 1. So its hypotenuse is, let me use a different color. So its hypotenuse is square root of 2. For in here, so we have 5. So that's 5 squared plus 12 squared. 5 squared plus 12 squared, that's 169. Square root of 169 is 13. So we have square root of 2 for hypotenuse for f sub 1 and 13 for hypotenuse of f sub 3. So knowing that, we now write 1 over the square root of 2. 1 over square root of 2. Then we have f sub 2. Oh no, I'm sorry. Let me do that again. Since we are doing the x, right? So this should be the assumption is to the right. Okay. I got used to doing the y first. Sorry. But nevertheless, for our 141.4, the x and y ratios is the same. 1 over square root of 2. Okay. Next would be x component of f sub 2, that is 300 sine 60 degrees. So that's plus 300 sine 60 degrees, because our 60 degrees is measured from our vertical, not from our horizontal. Next, For our f sub 3, that's 260 plus, still plus 260 times our ratio would be 12 over 13. And the lone wolf, f sub 4x, which is 240 sine 30 degrees. 240 sine 30 degrees. Now this is equal to 141.4 divided by square root of 2. So we have 99.98489 886 plus 300 sine 60. We have 259.807 6211 plus 260 times 12 divided by 13. That's 240 minus 240 sine 30, and that is 120. So our F sub R, the x component of our resultant force is 99.98489,886 plus 259.8076211 plus 240 minus 120, and that is 479.79252 and in pounds. Okay, next. The y component of our resultant force is equal to the sum of all the forces in the y direction, assuming upward positive, and therefore this is equal to, we start with our upward forces, so that's all forces except f sub 2. So f sub 1y, 141.4, 141.4 times 1 over square root of 2 plus our f sub 3, because 3 is going up, that's 5 over 13. So that's 260 times 5 over 13 plus our f sub 4y, 240 cosine 30 plus 240 cosine 30 degrees minus our 300 cosine 60. 300? 300. 300 cosine 60. Cosine 60 degrees. So we write this is 141.4 divided by the square root of 2 is 99.9848 98489886 plus 260 times 5 divided by 13, that's 100 plus 240 cosine 30, that's 207.84609 69,846,0969 minus 300 cosine 60, and that is 150. So our f sub r, or the y component of our f sub r, is equal to 99.984,89886 plus 100 plus 207.8460969 minus 150, and that is 250,708,309,958 pounds. So for our magnitude of F sub r, we have F sub r is equal to F sub r x squared plus F sub r y squared is equal to the square root of 479 479.79252 squared plus 257.8309,958 squared. So our F sub r is equal to 479.79252 squared plus 257.8309958 squared. Take the square root, that's 544.6812689 pounds. This is our resultant force. Direction of F sub r. So this is theta is equal to inverse tangent of fr sub y over fr sub x is equal to tangent of 257. Let me zoom out a little. 257 257.8309958 divided by 479.79252. So theta is equal to 257.8309958 divided by 479.79252. So inverse tangent, and that is 28.2527 degrees going up to the right. This is our direction. Now, in order for us to find the distance of our f sub r from point O, which is here, or point O, we must do moment summation. Moment summation. M sub r. This is the moment, resultant moment about point O is equal to the sum of all moments that acts about point O, assuming counterclockwise positive. Now, if we can observe here, let me redraw. Okay, so you have this is our y to the our x, and our point O is located here. Now, since our resultant force is going up to the right, and we don't know exactly if our resultant force acts counterclockwise or clockwise about point O, because we can have either our resultant force is this one, right? Because going up to the right, this is still our theta, or pwede pod nga diri, F sub R, because still this is theta going up to the right. So it can be that this is its perpendicular distance or this distance. We don't know. Now, unlike our previous examples wherein it is specified that the line of where our line of action intersects a certain structure, let's say a certain beam or boom or column, in here, we are not really specified. We don't know what is our reference. But we do know that if you want to locate the distance of our resultant force from point O, we can only rely on the concept of moment, which is the force, the resultant force, times a certain perpendicular distance from the point where we are uh, calculating our moment. But again, we go back to our dilemma wherein whether we follow if our F sub R is indeed kanibang pula or kaning blue. So what we can do is we will first do moment summation without considering usa our F sub R. So that means we take moment about M sub R is equal to the sum of all moments. So that is moment is equal to, again, we are assuming counterclockwise positive. So for our F sub 4, which is 240, we will not consider their forces because their perpendicular distances is 0. But nevertheless, atong ibutang para mapakita gyud no. So we have first is we start with 1, 2, 3, 4. So we have F sub 1. The only thing that we'll consider F sub 1x is one that follows a clockwise moment F sub 1x. So that is negative 141.4 times 1 over square root 2. Now the perpendicular distance would be 1, 2, 3. Because take note that our F sub 1 is applied here. So that is 1, 2, 3. So times 3 feet times 3. Next, we have our like again, F sub 1 y. I will just write it here. Minus 141.4. Again, in your solution, you don't have to write it here because again, the y component will be 0. But for the sake of discussion asa man sa f sub y, anong wala na appeal and all, ako ra gipakita ang nag-multiply nito siya with 0 because mo nang iyang perpendicular distance from O. Next, we have the x component of f sub 2, which is 300 sine 60 degrees. So we have, and it follows a clockwise moment. Minus 300 sine 60 times its perpendicular distance. So that is from 0.01 to 3, 4. times 4 feet, of course. And then next, the y component of our 300, which is going down, so it creates a clockwise moment. So that's 300 cosine 60, and still from point O, 1, 2, 3, 4. So this is minus 300 cosine 60 degrees times 4. Now, I will not continue here. I will just bring the next part down here. Okay, next, so we have accounted f sub 2. Let us do f sub 3. Now, f sub 3, the y component of our f sub 3, it's going up. So it creates a counterclockwise moment. So that's 260 times 5 over 13. So that's plus 260 times 5 over 13. And the perpendicular distance is still 4 times 4. Next, the x component that is going to the right, so it creates a clockwise moment about point O, and its perpendicular distance is 1. So that's 260 times 12 over 13 minus 260 times 12 over 13 times 1. So we have accounted f sub 3, and again, let's just write f sub 4. F sub 4 is 240 cosine. I'll just add it here. 240, right? So that's 240 cosine 60, 30. 30. Cosine 30 either way times 0 man siya. And then plus 240 sine 30 sine 30 degrees times 0. Like I said again, pwede ra kayo nga dili na isulat ang kaning tulo ka mga forces. Unsa ni mga tuluha kani siya, and kani siya. Okay. So we write our answers here. So this is equal to negative 141.4 times 3 divided by square root of 2. So that's negative 299. 141.4 divided by square root of 2 times 3. 299.9546 minus, we start at 300 sine 60. 100 sine 60 times 4. That's what, negative 1039.230,485. Okay, and then we have minus 300 cosine 60 is 150 times 4, that's 600, minus 600, and then plus 260 times 5 divided by 13 times 4 plus 400, and then minus 260 times 12 divided by 13 times 1, that's 240, minus 240. So if we do summation, moment is equal to negative 299.9546966 minus 1039.230485 minus 600, minus 600 plus 400 minus 240, and that is negative 1,779.185,182 pound feet, pound foot. So if you can observe that we ended up with a negative answer, so it means that the correct sense of our moment, resultant moment, is equal to positive 1,779.185,182 pound feet clockwise. Clockwise, or we write in terms of arrow, clockwise. So therefore, if we go back here to our dilemma, if whether kanibang color red nga F sub R or kanibang color blue nga F sub R. Now, if we look at it, si color blue creates a counterclockwise moment about point O, and si F sub R nga red creates a clockwise moment about point O. So therefore, we know that our resultant moment is equivalent to F sub R times the perpendicular distance, which is equal, this is equal to 1,779.185,182 pound feet. So we substitute our value for our resultant, which is, let me lasso this one. Copy. Anyway, so this is, let me delete lang the pound. Okay. So this is F sub R times, okay, D is equal to 1,779.185,182 pound feet. Divide both sides by the constant in the left side, 544.6812689. 544.6812689. So our distance from point O, where the our line of action of our F sub R passes through, is 1,779.185,182 divided by 544.6812689 is 3.266470289 feet. So this is its distance from point O. Now this is not just any distance, but the perpendicular distance. So if we redraw our XY axis here, this is our Y, this is our X, and this is our point O. And we have established already that all our force system creates a clockwise moment about point O. So let's say this is our F sub R, and we follow the line of action, and this is our D nga 3.266470289